So guys, the question that we are solving today is this: find peak element in return its index. And this question has been asked in the companies like Amazon, Uber, Microsoft, Roblox, Snapchat, and we are going to solve this question using binary search. Let's see how we are gonna do that. So the question says that we are given an integer array and we need to find the peak element and return its index. Means we need to find an element that is strictly greater than its neighbors. For example, if this is the array, then you can see this 3 is greater than both of its neighbors, its left neighbor as well as to the right neighbor. So in this case, this 3 is going to be the peak element and we will simply return the index of this 3. Okay, now one more thing that is mentioned in the question is an array can have multiple peaks. For example, if this is the array, then you can see this 2 is also a peak element and this 6 is also a peak element. So an array can have multiple peaks, and if this is the case, then we can return the index to any of the peaks. Either we can return the index of this 2 or else we can return the index of this 6. Now one more thing to note here is in the problem statement it is mentioned that we can assume -infinity at both the ends of the array. It means that the edge elements can also be peak. This can also be peak and this can also be peak. How it can be possible? See, we will handle the edge cases like this. We will check this edge elements with only the right neighbor. Same for this. We will only check this element with only the left neighbor. We are not going to check these elements with the neighbors outside the array. No. So now coming back to the main thing, that is how we are going to apply binary search here. See, if you carefully observe this array, you will notice that this array is first increasing and then decreasing. So what does it mean? If this is the start pointer, this is the end pointer, and definitely this is going to be the peak. What we need to observe? We need to observe two things. First, is my mid element lying on the rising side or is my mid element lying on the falling side? If my mid element is lying on the rising side, I know that my peak element will lie ahead. Make sense? And if my mid element is lying on the falling side, for example, if my mid element is lying somewhere here, so I know that my peak element will lie behind this. These two conditions we need to check, and that's how we have done the same thing in the code. First we handle the edge cases like this, and then we apply the binary search here. Binary search, how we have applied? We first calculated the mid element and then we are checking if this mid element can be my peak by checking this mid element with both of its left neighbor as well as to the right neighbor. If this condition is true, then it means that mid element is going to be my peak element. So we are just simply returning the index of that. But if that is not the case, I am checking is my mid element lying on the rising side. So in that case, we will just shift the start pointer to mid +1. But if we are on the falling side, that means we need to come back. We need to come back to search to look for the peak element. So for that, we will just shift the end pointer to mid -1. And that's how we have solved the question, and I hope you got the logic now. You can take a screenshot of this code or else you can save this video, and I will see you in the next video with another DSA concept.